Hey everyone, today I'm doing something that I probably do more than anything else, which is custom cables. And I'm doing the custom cables for this little K-Subs S3 build here, which I'm absolutely loving. There'll be a build log for this soon on the channel. And I thought I'd take you through exactly how I build my custom cables. This is something that I've only really briefly covered in a guide in the past, quite a long time ago. And I recently started a new custom cable guide. This is part 3 of that. In the first 2 parts, I covered all of the necessary tools and materials that you're going to need, not just for building custom cables for your core components or extensions, but for everything, for fan cables, for lighting. I also covered how to get your cable lengths. So lots of important information in the first 2 parts. And because I've already covered all of that, today we can get straight into it, into what people really wanted to see, which is actually how to build custom cables. So you can see that I'm in the middle of it here. I've already completed the 8-pin EPS, so this is kind of what we're going for. It's a metals theme, really, in this build. We have, copper, silver, and some black. So this is mdpc-x sleeve with Ice Mod's cable combs. And I think it's either titanium or platinum grey. I don't know why, but I always get those confused. Even though I know like every mdpc-x color, and I've been using it for, 10 years or something. But I also have the rest of the cables for the core components laid out here ready to go, the 24-pin and both of the PCIe. And you can see I'm about halfway through. I've already cut the cables to length, crimped on the pins. I have the connectors here that I'm going to need. I already know the power supply that I'm using, which is the Corsair AX860i. That's very important because each power supply has a specific pinout. So step 1, after you have all of your tools and materials figured out, you have all of your cable lengths. The next thing is to start cutting lengths of wire at your cable lengths. So for this I have a 1 meter ruler, and I just measure off one piece of wire. I cut that to length, and the way I do it, people set up jigs and all kinds of things for this, and I probably should set up some sort of a jig with a guillotine or something to make this more productive. But I just line up the 2 ends, pull them taut, check the 2 ends again, and then cut. Now, this may seem simple, but you have to make sure you use that same original wire for the measurements every single time. Otherwise, you could introduce an error which becomes exponential, because you keep kind of making the same mistake over and over again with the technique you're using to cut it. If you're really careful, you can get these exactly the same. You need to pull them nice and taut, mainly if the wire's not perfectly straight like this one. This is extremely important. If you don't get all of those lengths the same, later on you're going to have a cable that looks kind of, like this, with bits sticking out of it, and it looks absolutely terrible. So the next step is to strip the ends of the wire. Now you can really just use whatever strippers you want. I, for a very long time, have just been using a normal cheap set of strippers, but now, as I'm really trying to speed things up, I find that you need to put too much pressure on the wire, like that, and it puts this kink in it, and then you have to spend time getting that out, and it kind of stays there sometimes. So because of that, I don't really like it, and so I've started using this style. The problem with this is, even though it does have this adjustable thing, you can't actually get it as short as you want it to be. But I think this is just a cheap set, but you can eye it up. Now, the amount that you strip is extremely important. It needs to be 4 millimeters exactly. And this pretty much applies to all pins, but some of the bigger pins like Molex, you might want to go 5 millimeters. And then obviously the really, really small pins, like fan pins, you might want to go 3 millimeters. But you'll know as soon as you put the wire into the pin how much you need. But whatever you do, it needs to be exactly the same every time. Because you might have gone to all this trouble getting all your wire lengths the same, but if you strip in a different spot, it's going to change those lengths. The next step is to crimp on the pin. Now, the crimpers are very specific. You can't just buy these crimpers at a hardware store. You need to buy these from, mdpc or something. Crimpers that are specifically designed for this purpose. And yeah, this is a set of mdpc crimpers. My favorite, absolutely beautiful. And they work extremely well. There are actually a couple of little tricks with these, and also, well, any set of crimpers I find, I loosen off the tooling in the end so that it floats freely just a little bit. I find that really helps. Now, you can see that these only have two different sizes, and I like to do a lot of different strange cables that no one really attempts, and because of that, I like these which have different sizes. So if I'm just doing, ATX pins, I'll just use this all day. But if I'm doing strange sizes, I like to have this. And this works great for ATX pins too. So, you could get away with just using a set of these. I'll put a link in the video description to these and mdpc-x crimpers and everything else that you're going to need. Now, the pin has two crimps on it. And this goes for basically every pin. Although they all look quite different, some of them a bit similar, but Molex compared to this and then SATA compared to this, they look really confusing and different, but they're exactly the same in terms of the way they attach. The first crimp is for the insulation on the wire. The second crimp is for contact for the wire itself. Now the first one is not really so critical. This one for contact, the inner one, is absolutely critical, but the way you crimp, this is the most important part. If you don't get this right, you're going to kill your components and nothing is going to work properly, and you're going to have a lot of trouble diagnosing where the problem is. So what you need to do, you can see what I've done here. The insulation runs through the first crimp because that crimp is going to grip the insulation. The second crimp has the wire inside of it, as you can see. Now the wire needs to run at least to the end and line up with the end of that second crimp. If it overhangs it a little bit by 1 mil or even 2 mil, that's okay. But you don't want it to go up inside of the pin because that can start to interfere with connections and things. So where it is right now, lining up exactly with the crimp is perfect. Now, because you need two hands, you need to get a pair of needle nose pliers, squeeze the insulation crimp, and I also squeeze this crimp a little bit because I find they're usually too wide to fit inside of the crimpers. Now this is also extremely important. Now there's 3 sizes. Which size you use, it just needs to work. I'm not going to say, because your crimpers probably could be different to the ones I'm using. It might be the middle one you need to use, or it might be the big one you need to use. It just depends what works. But for these crimpers, for the 16 gauge wire that I'm using and the ATX pins that I'm using, it's the big hole. Now this is actually quite simple but very important. The inner crimp, the wire crimp, needs to be lined up with the outside of the crimpers, precisely lined up. And you'll be able to take a look before you crimp. You'll be able to see the wires lined up with the inside of the crimps lined up with the side of the crimpers. You start to squeeze, make sure it's all perfectly aligned. And if you're happy with it, also the direction of the crimp, the open part facing upwards, squeeze all the way down as far as you possibly can. Sometimes the pin can get stuck inside of the crimpers. Just give it a little wiggle and it'll drop out. Now you can see that is a perfect crimp. Both of those crimps are wrapped around and bent into the wire. You can see that the insulation even has a line in it from the insulation crimp because it's punched right into it. The other one, it's all symmetrical. The pin is perfectly straight. It hasn't been bent. None of the pin up here, these little tabs here, have been crushed or anything. You need to watch out for all of that. If there's any misshapenness of the pin, you're doing it wrong. You need to do it again. Now, if it is slightly bent, it sometimes happens, they get bent that way a little bit. You can bend it back, but not very far because, it's at risk of snapping. It's only very thin just there. That's why they can be misshapen by a bad crimp so easily. And I always do the pull test as well. Just give it a pull as hard as you can to make sure that it's on there really securely. But you know, if it's a good looking crimp, then there's no doubt that it's on there securely, and you really don't need to worry about it again after that. Okay, now you need to crimp a pin onto the other end, and this is also really important. Your pins need to face the same directions. With Molex pins, you don't need to worry because they rotate, but with every other pin, they need to face the same way on each end. And that is because if they don't, you're going to end up with a very twisted cable, and that's why actually one of the reasons I redid this, it ended up a bit twisted. I didn't do these. One of my employees did, who was in training. He's now left and gone down south, and I'm on my own again. That's what seems to happen. A lot of people think that this, you know, this job looks great and looks fun, and to me it really is. I love it, but it's very hard and there's a lot of pressure. And if you make a mistake, you know, you're in big trouble. I mean, I let my employees make mistakes, and all the pressure and trouble comes back on me. But I'm just saying that to a lot of people, they think it's going to be fun and they're going to be able to play with hardware and everything. But when they get here and they start doing this for days on end, you know, their mind starts to crack. Okay, so keeping the pin upright, just turn it around, you know, however you want to do it, it doesn't matter. But yeah, usually right before I'm about to squeeze it, I just have a quick look at the other end, make sure it's correct, give it a bit of a twist side to side. Actually, the other thing that I sometimes do, and this is probably a better way of doing it, is get it upright and then put a little kick in the end of the wire, just bend it to show you where vertical needs to be. And then when you crimp the pin on, make sure that it's vertical in the direction of that little bend. So again, with the needle nose, using the insulation crimp to hold the pin on the wire nicely. You know, don't squeeze the hell out of it, but it needs to be firmly on there so that the pin isn't going to move during the crimping process. And then squeeze the other one, not for the purpose of holding the pin on the wire, but for the purpose of reducing the size so that it fits into the crimper. So same thing again, check your crimp, pull on it, make sure it's the same direction as the other one. Yes, it's perfect. Okay, now we have a wire which is ready to sleeve. So I already have some sleeve cut for this, but now this is another hard part, getting your sleeving lengths right. It's different for heat shrinkless compared to using heat shrink. Today we're doing heat shrinkless. I mean, everyone's doing it now. I highly recommend it. It is quicker, easier, because you don't have to worry about lining up all of the heat shrink. It also is far more durable and is going to last a long time, because we're actually, with heat shrinkless, melting the sleeve, you know, into the pin. It melts all into here, attaches to the insulation. You will never pull it off. But I run it from, now see if we can see this, from there. So that's the inside of the wire crimp, the inner crimp. Okay? Hold it, pull it taut to the same spot on the other end, the inside of the wire crimp. Now whenever you're cutting, manipulating sleeve, you always need to melt the ends immediately. As soon as you've cut it, melt both ends. Now I highly recommend this, particularly for beginners, but for everybody. It burns at about, I think, 600 degrees. There is no naked flame. That's the most important part. Naked flame, I don't know, it's difficult to deal with, mainly for beginners, and I don't like using it. You know, you can easily melt parts that you don't want to melt, and you just have a lot more control with this, and you can use it, you know, inside of the case for doing little bits and pieces at the end of your build. Okay, so we're just going to push the wire into the sleeve and just do that. Now, when you melt your sleeve, you want to melt it so that it's about halfway across the wire crimp. So halfway across the wire crimp, is a perfect position. Any further forward than that, and it's going to interfere when you try to push the pin into the connector, and it's actually going to, if it's too far up, completely prevent you from getting that pin into the connector at all. So now I have a piece of heat shrink which I've just pushed over the sleeve. Check for alignment again, make sure that it's positioned, and you know the heat shrink needs to come just over the end so that the whole thing is covered. It needs to be long enough so that the heat is not going to get onto the sleeve and melt the sleeve down here where it's going to be in view. The whole goal here is just to melt the very end, which isn't going to be visible. It's going to be inside of the connector, and you really need to smoke it up. Like, it needs to be boiling and smoking. So you can see that I have the burner on a little bit of an angle back so as not to get heat down onto the part that we don't want it to touch. And that's probably enough. Okay, so about 10, 15 seconds, 20 at the most, and get your nips, put a little cut in the heat shrink. You don't have to cut it all the way up, just a little cut. You need to wait about 10, 20 seconds again for it to cool a bit. You don't want it to be too hot when you pull it off. Actually, you'll know if it's too hot when you pull it off because the melted area gets all kind of strands in it. And okay, that wasn't perfect. It's because I'm trying to do this through the viewfinder and it's looking microscopic. But it will work. There's no doubt about that. But yeah, it's melted down a little bit too far. I like to melt only about 3 or 4 millimeters. And it's also gone up a little bit too far. You can see it's gone past that point, so it must have slipped as I was trying to do it. Now, if you manage to get your sleeve lengths perfect, exactly where you want them, you should just be able to pull this taut. And I mean really taut. You know, you actually might want to sit there kind of going like this for a little bit to try to get it as taut as you can. But then the last one you do, pull it as taut as you can. You know, really squeeze it tight, pull it up, and it's exactly where we want it. You see that? Even though it's really taut, it's right where we want it. So that's perfect. Otherwise, you know, if it's too long, just cut it down, just get the side cutters in there and just slice it off and then remelt it. Even though you're going to melt it again, remelt it before you put this on. Otherwise, you could run into problems, and that's not quite melted enough either. So doing the same thing, but this time you have to be really concerned with holding that in position. You don't want this sleeve to be loose. If it's loose, it looks terrible and the wires don't train properly. If it's really tight, they look amazing. They all look symmetrical and even, and the cable just trains perfectly. You know, you basically just push it into position one time and that's it. It stays there. So this time, I found that the sleeve, the different colors seem to have slightly different properties when it comes to melting. So this actually melts a little bit more than, you know, what I'm used to with the black that I've been working on for the past few days. So I've just melted this a little bit less than I just did previously. Now you can see that it's a little bit shorter, which is good. It's about 4 millimeters all the way around. It's exactly how I want it. And you can see that, you know, it's positioned. By the time it melts, it comes, you know, to the end of that inner crimp. But when you start it, it needs to be in the middle of it. But obviously when it melts, it kind of flows out a bit and squashes down. So that is a perfect crimp and sleeve right there. That's what it's supposed to look like. So that when it goes into the connector, and they only go into the connector one way. Molex, it doesn't matter because they rotate, but every other pin, it's generally, you know, the pin facing up where the latch is, the connector facing up where the latch is, that's where the pin needs to face upwards to. So that will just click into position, and you'll see the end of the pin. It should be, you know, straight inside of the connector. If it's twisted either way, that's no good. need to do it again. Well, not really. I mean, it'll work, but it means that there's pressure back on the wire and it's going to give you a terrible looking cable. And you can see that our melt is not sticking out the bottom of the connector, it's all hidden inside. So that's it, you know, I can make as many of these as I want and plug them in and thread on the cable combs. But there is something else. You have to figure out your pinouts, and the pinout for every power supply is different. And so on the cables for the core components, the 24 pin, the PCIe, the EPS, the ATX, you need to know the pinouts. The best place to go for pinouts is the pinout repository. I'll put a couple of links in the video description to where you can go find pinouts. It's not as hard as it sounds. So that's it, guys. I hope you find this information useful. Let me know if you have any questions. Actually, if there's enough questions, I might do like another Q&A style video and demonstrate some of the answers also, because you know, custom wiring is extremely important for high-end water-cooled systems. Without it, systems just look terrible. I mean, there is so much extra cable length. Like, even if we didn't have sleeve and we were just doing it for the purpose of getting the correct lengths, I think that is the most important part. You know, the sleeve is just the icing on the cake, a nice little extra. Getting the lengths is really the main thing. Anyway, that sums up this video, and remember that none of this would be possible without our patrons.